the axis and your vector?
Doesn't matter. It actually, yeah, the cosine's always going to be positive, because the angle's always between negative pi over 2 and pi over 2. Okay, anyhow, K is here, and let's draw N. I exaggerated the angle here, but it's still, you know, here's your N, still projects back on here, right? So in the plane of N and K, the surface viewed from a point, viewed at a perpendicular to that plane, is going to just look like a line segment, right? N is here, sorry, N is here, K is here, right? So from where you're looking, the surface is perpendicular to this. Now, surface perpendicular to the N, if you're looking at it from perpendicular, just looks like an edge, because you don't see any of the perspective, okay? Now, your region down here, viewed from the same angle, is just a segment. And this edge and this edge, or this segment and this segment, just represent what you see when you look at the surface. It has the same depth. This has the same depth into the board, same, for both of these, okay? And you can think about that and reconcile it. So that the ratio of areas is just the ratio of this to this, because this is perpendicular to this, and this is perpendicular to this. Now you want to think that through and make sure you really understand it, that the ratio of the areas is just the magnitude of N over the magnitude of K. Well, K is a unit vector, so that's just the magnitude of N. Okay? And what's the magnitude of N?
Square root of 1 plus fx squared plus fy squared.
It's equal to this, right? And that is what? That's just the magnitude of Tx cross Ty. Okay? And from that, the surface area corresponding to region R in the xy plane, well, the ratio of the areas is this, meaning the area of any increment is magnitude of Tx cross Ty at the sample point times your delta x delta y, right? So it's just this times your area increment. And when you do the partition, as you need to do, and sum everything, okay? And do the limit to the integral, you find that that's what you get. It just comes down to this, because once you know what happens on the increment, you do the partition thing, which you need to do. The third time I say it, but the first time it's going to actually appear on a video. You're a more powerful engineer if you can build your integrals. You don't know calculus well enough to really use it unless you can build integrals using a partitioning process or something equivalent, but anything equivalent is harder, okay? Otherwise, you're just using formulas. And that's substantial skill in itself, but you're more versatile. You can go deeper. You can adapt things better if you know the mathematics and can build things up from this. Okay, from what happens in an increment. Now, a lot of times when you get good at it, you just say, here's what happens in an increment, so that's got to be the integral. And maybe you don't go through the partitioning process. But you need to go through the partitioning process in this course so you know when you can skip it, when you can't. And you can always go back to that process and make it rigorous, okay? You know, we just landed another probe on Mars. I think that's the 8th one in a row we didn't crash. And we crashed it because of inattention to detail by engineers, okay? I think it was by engineers. Can't imagine they would have let anybody but an engineer do it.
I hope not.
It might be, you know, and of course the engineers are over the thing, so if they did, it's still their fault. I mean, if they let somebody that wasn't qualified do it and dang it, I'm over 15 minutes. Shucks. Okay.